Alright, so in this video, we will now look at how to apply the formula for area of triangle. Okay, quick recap, which is half AB sine C. How we can apply this formula to solve problems involving triangles. Okay, so you look at three examples. So if you have your textbook with you, you can actually attempt to do it on your own first. Okay, we will look at try it first, and then try it 9 and try it 10. So if you're interested in attempting the questions on your own first, please pause the video right now. Okay, so now let's take a look at how we can apply this formula to solve the question in try 8. So let's take a look at try 8. In triangle XYZ, XY equals to 6 cm, so it's already labeled in the diagram. YZ equals to 7 cm, labeled in the diagram. Angle XYZ equals to 130 degrees. Okay, find the area of angle a triangle XYZ. Okay, so similar to the listen, look at this question. Okay, we can understand why we can't use half times times height because height is not given. However, before you can use this formula, please check. Okay, is this angle an included angle? Is this angle an included angle? Because if it is, so if it is, yes, then we can use the formula half AB sine C. If let's say in the questions, the angle is not an included angle, then you need to find that included angle itself. Okay? So in this case, because it's an included angle, we can straight away proceed. Area of triangle XYZ. Okay, so rewrite back the formula half AB sine C. So in this case, we will just label this A, this will be my B, and this will be my C. Okay, remember, include the angle C. So half multiplied by XY multiplied by YZ multiplied by sine angle XYZ. Okay, substituting in all the numbers equals to half bracket 6 bracket 7 bracket sine 130 degrees. So we will have 16.087, and rounding off to 3SF, we have 16.1 centimeter square. And that's it. All right, so in try 8, a very simple way of how we can apply the formula to find the area of triangle. Let's take a look at try 9 now. So in try 9, we don't have a triangle drawn for you, but we do have the information given. So in triangle ABC, BC equals to 9 cm, CA equals to 7 cm, and the area of triangle is 28 cm square. Find the possible values of triangle ACB. Now, as of all other geometric equations, if there are no diagrams drawn for you, it will always help for you to draw a simple diagram. It doesn't have to be accurate. Okay, we are not interested in the accuracy of the diagram. We are more interested in making sure of the positions of the length so that we know which is the included angle, where the length is, and everything else. So BC is 9 cm, CA is 7 cm, and then we have angle ACB, which is here. So again, same thing, is it an included angle? So check included angle, and we realize that the angle is between the two lengths as given. So yes, it's an included angle. We can make use of the formula half AB sine C. Okay, so now what we need to do is we need to work backwards. So again, let's start with the formula again. Area of triangle ABC, okay, is given by half AB sine C. Okay, so half A can use any other length, so let's just put 7. B, I can use the other length, which is 9 cm, and then sine C. So sine of angle ACB. Now, area of ABC is given by 28 cm square. Okay, so simplifying this formula, I will have sine angle ACB is equal to 28 divided by whatever that is the number here. So half multiplied by 7 multiplied by 9 is given by 31.5. So angle ACB is equals to, so sine inverse 28 divided by 31.5 equals to 62.734 degrees. Okay. And at this point of time, most of us will leave the answer here and we will be happy and we'll celebrate. And then when you get back our results, how come this answer is not full marks? Now, over here, I hope you have noticed that the question was very explicit in saying possible values, plural. And why is it plural? It's because we go back to 7.2, we have this following rule of obtuse angle, where we have sine 180 degrees minus theta is equals to sine theta itself. So which means that angle ACB can also be, or angle ACB can also be 180 degrees minus 62.734, which will get me 117.266 degrees. And of course, you need to round off to 1 dp for angles that are not exact. So angle ACB is equals to 62.7 degrees, or angle ACB is equals to 117.3 degrees. All right. So over here, two things to note. Number one, again, check there is an included angle. Second thing to note, because we are talking about sine of an angle and we are looking for an unknown angle itself, please remember that the sine of the obtuse angle is always the same as the sine of the acute angle. So you will have two solutions. All right. So let's take a look at the last try 10. So try 10 is where we explore problems involving shapes other than triangles, but we will still break them apart into triangles to help us solve the question. Okay, so in this case, let's take a look at this question. A regular hexagon is inscribed in a circle of radius 6 cm. Find the area of hexagon. So again, since there is no diagram drawn for us, let's draw a diagram. Oops. How do I get a proper circle? Nope. There we have it, a circle. Okay, and let's draw a hexagon inside. Okay, so one, two, so 1, 2, 3, 4, 5, 6. And it's helpful to know that each of the length is equal because it's a regular hexagon. So how can we find the area of this hexagon? Now you realize that the radius is 6 cm. So if I have a center over here and I draw to the edge of each of the point on the hexagon, you realize that I will divide my hexagon exactly into 6 equal parts. And each of the side of the triangle will be 6 cm, 6 cm, 6 cm, 6, 6, and 6. Okay, so now the only thing left, if let's say I'm looking at one specific triangle, let's take a look at this specific triangle. You realize that I already have the length over here. The only thing I have to do is to find the angle over here. And you realize that to find the angle over here, because it's 6 equal triangles, I can just take 360 degrees, which is the area in a circle, divided by 6. So I can do it two ways. I can actually divide my steps into different parts. Okay, or I can just simply write down the area of hexagon is simply 6 times the area of the triangle over inside. 6 times area of triangle in the hexagon. Okay, and let's just put in the formula for the area of triangle. 6 multiplied by half AB sine C. Okay, and because I have my a and b, which is 6 and 6, so 6 multiplied by half, bracket 6, bracket 6, sine c, so sine c will simply be my angle included in between the two lengths, so it will be 360 degrees divided by 6. All right, so you can just do this slowly, or you can just type everything to your calculator, whichever you prefer. And you should get your answer as 93.531. 93.531, and let's round this off to 3SF, so 93.5 cm square. All right, so this is for part A. Now let's take a look at part B. The parallelogram PQRS with PQ equals to 2x, QR equals to x, and PQR equals to 110 degrees. If the parallelogram and the hexagon in part A have the same area, find the value of x. So in this case, we realize again, we can actually divide the parallelogram into two equal triangles. Okay, how do you know they are congruent? Because of the fact that these two lengths are equal, 2x and 2x, x and x, and 110 degrees and 110 degrees. So just a quick recap on chapter 6, congruency and similarity. We can actually prove that PQR, we can prove that triangle PQR is congruent to triangle. So P corresponds with R, so R S P. Okay, and the result will simply be SAS, where A is the included angle between the two sides. Okay, but this is just a quick recap. You don't have to prove this in your exams if it's not asked of you to do so. Okay, but I'm just proving it to you to show that the triangles are congruent. Okay, but let's look at the problem. Okay, so if the parallelogram and the hexagon in part A has the same area, so we have the area of the parallelogram is given by 2 times the area of the triangle. So 2 times area of triangle. So just write down the formula, half AB sine C. Okay, so area of PQRS is simply 93.531. Remember, use the 5SF figure for your workings. Even better is if you use your original answer in your workings for better accuracy. Multiply by 2, oops, 2 multiplied by half. So A is given by 2x. Doesn't matter, you can label this as A or B as long as you label each of them correctly. I think the more important part is the fact that the angle over here is an included angle. Okay, so sine 110 degrees. Okay, so simplifying your workings, we will have 2x squared sine 110 degrees is equals to 93.531. So to find x squared, I have 93.531 divided by 2 sine 110 degrees. Okay, so we will have x equals to, okay, now algebraically we will have x equals to square root 93.531 over sine 2 sine 110 degrees, or always remember, when I square something I will have the negative value. But in this case, because I know x represents the length, okay, I will just immediately show my rejection over here. Okay, now in some cases, or some examiners will close one eye if you don't include this part. Okay, some examiners might not. Okay, but I guess because we aim for mathematical perfection in our presentation of our working, let's just include it, and we make sure that we include the reject part over here. Okay, if you can actually put the reason for rejection, that will be even fantastic. But if you're not sure about the reason, don't put it. Okay, if you're unsure about the reason, don't put it, because then you are just marking yourself down. Okay, but in this case, we are sure that the reason is simply because reject because length cannot be negative. Okay, so we just put this here just to be perfect on this. Okay, so for exams, like I say, some examiners, some markers will close one eye when you don't include this part, because they will assume, or rather they will assume that you know that length cannot be negative, and that's why you don't even include that in the answers. Okay, so if I solve this question again, always put in phi SF first. So x equals to uh so you put x equals to square root 93.531 divided by 2 sine 110, and we have x equals to 7.0545. Round off to 3SF, x equals to 7.05. Okay, and in this case we don't have units for x because x is just a number. The units already put there xcm, so you put x equals 7.05 cm, then it will be x, then qr will be 7.05 cm. Okay, so just think of that. Okay, I know it's a bit of small things, okay, but like I said, perfection in mathematical presentation. All right, so with that, I've come to the end of the examples for area of triangle. In the next three sets of videos, in the next set of videos, we will explore sine rule followed by cosine rule. Okay, same thing. We will have the introduction of the concept, and then followed by the proof, and then examples. All right, have a nice day ahead.